everybody. Good morning. Thanks for joining me for math today. Happy to have you. Thank you for being on time, as always. Much appreciated. Today we are going to be wrapping up chapter 4. It's actually the last few pages of the textbook. We made it all the way through textbook A. Yay! All right, so we will wrap that up today. If you looked ahead on the calendar, the chapter 4 test is scheduled for, let's see, today, right? So it does have to be done by tomorrow at 4. So plan accordingly. Again, there's not going to be any extra time past tomorrow just because it's the end of the semester. Okay, so I will do my best to grade your test as soon as I get it. But there may not be time for a retake. Again, I can't extend any submissions past 4 o'clock tomorrow afternoon. So keep that in mind. Make sure that you've done this review so you can crush that first attempt. All right, let's dive in today and finish up Book A. All right, again, we're reviewing, so our learning objective is to review some previously learned materials. Okay, in addition to starting our new book next week, Book B, which you'll have to dig out from the depths of the supply, wherever you set those supplies that you got in the beginning of the year, right? You might as well get out your new science book too. We're going to start a new science book as well. Okay, so we'll have a fresh math book, a fresh science book. We're also going to have fresh courses. Okay, you will see today I'm going to publish our new semester 2 courses, right? So you'll see instead of it saying Math 7A, it's going to say Math 7B. Okay, so there'll be new courses, a new calendar. The other courses will go away after semester 1. You won't see those anymore, and you'll only be able to access semester 2, but I do want you to be on the lookout for that. Also, we will have new Zoom sessions starting next week. It won't be this exact web address for our Zoom. I have to make new Zooms for a second semester, so you'll have to access those right through the new semester 2 courses. Okay, I just know some people save these links. Those are going away. We will have new Zoom sessions for our new semester 2 courses. Okay. All right. Anybody have any questions on that before we start tackling this review? All right. Most of you are old pros at this anyway. It's not your first rodeo, but just wanted to give you a shout out. Just a quick reminder. All right. When we started chapter 4, we started talking about direct proportions, right? Direct proportion, then we went on to inverse proportion. Okay, so we talked about either constantly increasing or constantly decreasing at the same rate. So take a look at, I have 2, 6, and 9 up here. Decide whether or not these are direct proportions, inverse proportions, or neither. Addie, did you want to talk about one of these or do you have a question?
I thought you were going to let us do one of these.
Go for it. Sure, I can do that. Which number did you want to take?
Number 2.
All right, that's all yours. Does anybody want to volunteer to grab number 6 or number 9? Yes, solely, and that's fine. Yep. all taken care of. Thanks for checking in though. Go for it, Sully. Which one did you want? Number 6 or number 9? 6 is all yours. All right, Sully's got his answer up there for number 6. Yep, that is a direct proportion. How do you know that, Sully? What things did you look for?
It starts at 0 and it's a straight line, and if you multiply each of the coordinates, I think they're called, you always get the same, or divide.
Yeah.
Yeah.
Yep, you got it. Yep. If we divide those coordinate points, if we pick someone on the line there, right, we're going to get the same number every single time, right? 1 divided by 1, 1, 2 divided by 2, 2, or sorry, 1, 3 divided by 3, that's also 1. You could keep going. That would match up consistently throughout. Yep, we're looking for if you've got a direct proportion. We've got 0, 0 is where our graph starts, and we want to look for a straight line. You do want to make sure your straight line isn't laying directly on top of the x-axis or directly on top of the y-axis, right? But we've got those criteria met. So yes, number 6 is a direct proportion. A direct proportion, you're going to see an increase, right? Direct proportion, both the x and the y values are increasing. All right, Addie, you saw something a little bit different on number 2. What about number 2? Told you it was an inverse proportion. You want to walk us through this?
So, I know when we see this table with X and Y lined with numbers, I automatically know that we have to times whatever X and Y is. And if all 3 or any numbers, any group of numbers you get has the same number. So for this instance, this is 100. This one is, it will be a inverse proportion, since when you multiply two at when you multiply 2 of these numbers, you have to get the same number every single time.
You got it. That's right. Very good. Yep. Okay. So, in an inverse proportion, you're absolutely right. This is an example of an inverse proportion. Nicely done, Addie. Okay. We want to look to see, first off, on our table, right? Are both of our values increasing, or are both of our values decreasing, or are one of our values decreasing? So in this case, we have our x increasing, but you can see the y value is not. So the y value is actually decreasing. It's going down. Okay. So that sets us up for a situation to potentially have an inverse proportion, right? A direct proportion would have both our x and y values increasing. So we know it's not that. Okay, so we do have the potential here for an inverse proportion. Okay, And Addie was right on the money when she said, hey, I know an inverse proportion. If I take my X and my Y value and multiply them together, I'm going to get a constant, right? I'm looking for a K, right? A K value, a constant value that is consistent throughout. So when I multiply each of my data points, right? 2 and 50, 4 and 25, and 8 and 12.5, I'm going to get the same number every single time. So in this case, Addie found that our constant was in fact 100. Each of these values did equal 100. Okay. All right. So this is one way to write our equation for our inverse proportion there. Okay. Does anybody remember the equation set up for the direct proportion? I know this wasn't on there, but it's going to help us with number 9. Does anybody remember the equation setup that we would use? X times Y equals K. That one is for an inverse proportion. Multiply an inverse proportion. Do you remember what we did over here to our coordinate points in order to get that constant value? We didn't multiply. You got it, Addie. We divided. Very good. Okay, so we're actually going to take our Y value divided by our X value, and that's going to get us our constant, our K, right? So this is for inverse proportions. Okay, this setup is for our direct proportions, right? We could also kind of rearrange this and set it up as Y equals K times X, right? That's another variation on this, right? This one's solved for Y. This one's also a way that you'll see that, okay? So looking at these, right, you can see that they're all multiplication or division, right? I don't see any adding and subtracting. So when I take a look at number 9, okay, and I want to decide, is this an equation show a direct proportion or an inverse proportion? Okay, I'm going to look to see, does it fit into one of these outlines? Okay, well, I've got Y equals, okay, so maybe I'll start over here. Let's look at this. Maybe it's a direct proportion. Maybe it fits into this line, this outline, right? Y equals some number times X. Okay, let's look to see if we've got that. Whoops, I erased too much there, sorry. Okay, that is not what I wanted to all erase. All right, so we're looking for Y equals some number times X. Okay, Y equals 1/2 times X. All right, that's looking good. But there's nothing else after our outline. That's it. All we need is some number times X. So does this plus 5 fit? No, it doesn't. It really doesn't. Okay. There's totally a shortcut for this. If you get an equation, sorry, Addie, I keep wanting to erase here. I'm trying to erase my own annotations and it keeps erasing yours. Let's see if I can get it. Nope. All right. That's all right. If you see an equation with a plus or a minus sign in it, it's never going to fit into one of these outlines. Never, ever, ever. It's not a direct proportion and it's not an inverse proportion, right? Our outlines only have multiplication or division in them. Okay. Never plus, never minus. You're never going to be able to cancel this out. Okay. Doesn't matter how you rearrange the equation, you're always going to have a plus or a minus sign in there. Okay. So that's kind of a little shortcut. All right. You guys are off to a rip-roaring start today. Let's keep that energy flowing. Let's take a look at numbers 13 and 16 on page 363. I've got some incomplete tables here. Number 13, the directions tell you it is a direct proportion. So you know there's going to be a constant. Okay. Again, remember, direct proportion Our equations are y equals k times x. You could also set it up as y divided by x equals k. Okay, so keep that in mind. That setup has to be true for every single data point. Okay, so look to find the constant. Number 16 is an inverse proportion. Okay, remember, in an inverse proportion, the equation is similar. It's a little bit different, though. It's the opposite of a direct proportion, right? Direct proportion, to find k, we divided. Inverse proportion, we're going to multiply to find our k value. Again, they tell you it is an inverse proportion, so you can assume that there is a constant k value here going on. Okay. All right, if anybody wants to volunteer as a tribute for number 13 and 16, the floor is yours. Otherwise, we can talk about it together. That's fine too. All right, Sully, which number would you like to tackle?
13.
It's all yours. If there's anybody that wants to tackle number 16, it's all yours. Carmen, you're in the, there she goes. I was just about to say, Carmen, you're in the Zoom twice. Do you want me to remove your other alias there? But I think she's having some internet. Hey, there we are. Now you're one person. I was just about to ask you if you wanted me to remove your other alias or your other doppelganger there, but now you're back to one person. So
She just got this new computer, so we were having issues this morning.
got it. All right. A little bumpy on the test run, but we'll get it figured out this morning. We just put up there the other equation for the inverse proportions. Again, it's just set up as y equals instead of k equals. Same thing, just another variation on that. And depending on what values you get, maybe you want to use x times y equals k. Maybe that's most helpful. Maybe y equals k divided by x is most helpful. All right, let's see. Number 13 is looking great, right on the money. You want to talk us through that one, Solly? Oh, if you're talking, you're muted. Oh, he's still writing. My bad. I didn't realize you were still working on that one. Go
No,
for
it's
it.
so I saw that 16 divided by I saw that 16 divided by 4 is 4, and then I know that everything else needs to be 4, so 8 divided by 2 is 4, and then 25 divided by 6.25 is 4.
Excellent. Yeah. So your thinking to take a look at that data point that they gave you where you got the X and the Y, you were right on the money to take a look at that in order to find the K value, right? So we know that when we divide our Y value by our X value, we're going to get the K, right? They already told us it's a direct proportion. So we know that this is going to be constant throughout. Every single time we take Y divided by X, we're going to get 4. So Sully said, all right, well, what number divided by 2 equals 4? 8, right? So 8 has to be the Y value that corresponds with when X is 2. Okay. And then we had to take 25 divided by some number, right? To get 4, that was in fact 6.25. Again, another way to look at it, okay, you could say, well, 25 is equal to our constant, which is 4, times some number. Okay, again, to give you your X value. All right, how many people got number 13? Excellent, well done, well done. Okay. All right, Sully's got to leave. Thanks, Sully. He's got somewhere to go this afternoon. Nicely done today. We'll see you later. Number 16. Addie said she was going to work on number 16, putting that up there for us. Again, number 16 is an inverse proportion. So we know that when we take our X and our Y value and multiply them this time, not divide, but multiply, they're going to all equal the same number. So we're going to want to look at the X and Y values that we got to find our constant. Actually, I won't even write up there. I won't mess up. Ah, sorry. Hold on. I'll put it back. Sorry. It's trying to erase my own stuff. I'm sorry, Addie. I think our text boxes and stuff are overlapping. So when I go to erase something, I accidentally hit the corner of your text box and it erases. All right, so yes, Addie correctly identified the constant there. That constant is 8. All right, so both the X and the Y values, when they're multiplied together, have to equal 8. So go ahead and fill in those missing values. You can use a calculator to help if needed. All right, nicely done, Addie. You want to talk us through it? Very good.
So, I normally always do the y equals k divided by x. So, doing that, I know immediately that to figure out what the constant proportion is, I have to first times 5 and 1.6 to get the constant, which is 8. So automatically I knew that I had to divide 8 with 2.5 and 2. So first I did 8 divided by 2.5, so I got 3.2. So I knew that was going to be the y product. Then I did 8 divided by 2 to get 4, which is the x product, and to figure out if the constant is actually 8, I did 2.5 times 3.2 to get 8, and 4 times 2 to get 8.
Very good. Excellent. Great explanation. All right. Again, we know Addie said, if you're going to multiply your X and Y values in your inverse proportion, it's going to equal your constants. So she found the remaining values there that when multiplied together would equal 8, and she used division to do that. Well done. All right, who went 2 for 2 on 16? Excellent. Very good. Let's keep it rolling. Ooh, now we put our proportions on a graph. All right, if you just look at this graph right off the bat, what kind of proportion is it? Is it a direct or an inverse proportion? You got it, Tony, a direct proportion. Nice job, Anna. Very good. Okay, direct proportion starts at 0, 0 is a straight line. Okay. They did tell us that in the setup here that it is a direct proportion. It looks like we're comparing the amount of gasoline to the cost. All right, so let's find the constant of proportionality. Let's take a look at this graph and find the constant. I'll put some data points on here. Again, it's a direct proportion. So when we take y divided by x, we're going to get our constant. Well, if you take 12, your y value divided by x, the corresponding x value there, which is 3, you're going to get your constant. You could also use 8 and 2. Who's got it? What's the constant of proportionality here? Nice job, Tony. You got it. 4. Very good. Yep. 12 divided by 3. Right. Again, if our coordinate point is 3, 12. Right, the y value we got was 12, the x value we got was 3. We'll divide those to get our constant. 4, very good. Where is, there's kind of a little cheater trick. Who remembers the cheater trick for a direct proportion to find the constant? It's kind of a shortcut. Where can you look on the graph for a shortcut for the constant of proportionality when it comes to a direct proportion? You got it, Anna. Anna said, hey, if your graph has x equals 1 on it, if you look where x equals 1, okay, we go up, hit the line, and go over, you're going to get your constant of proportionality every single time. That's the shortcut. It's okay if you don't remember. Okay, if you are like, I know that in a direct proportion, I'm going to divide my coordinate points to get my constant. That works every time too. But there is that little shortcut on your graph. If you look when x is 1, the y value will always be your constant. All right, what does 4 mean in the context of this problem? What does 4 represent? You got it, Anna, the cost of 1 gallon of gas, right? So K, our constant, is equal to the cost of 1 gallon of gas, right? So we know that it costs $4 for 1 gallon of gas. Nicely done. Okay, so each gallon of gas costs $4. Let's write that direct proportion equation. You can set it up a couple different ways. Usually for a direct proportion, we'll see this guy right here, y equals k times x. Go ahead and substitute in your k. What do you got for me? Addie knows, nicely done. Rin, Lucas, Maddie, Yangi, Elizabeth, Autumn, Carmen, you guys have been extra quiet today. What are you thinking? Take your constant. We just said the constant was 4. Go ahead and put it into the equation for K. Nice job, Anna. Very good. There we go. All right. Yes, yes, yes. Nice job, everybody. Y equals 4x. Very good. All right. If Luis spent $24 on gas, how many gallons of gas did he buy? You got it, Laura. You got it, Anna. Nice job, Tony. Nailed it, Annie. Addie, nice job. And we can put that into our equation, right? The dollar amount that he spent, that's on the y-axis, right? So that's going to be our y value. If he spent 24 sorry, if he spent $24 on gas, we know it costs $4. How many gallons did he buy? You got it, Lucas. What number times 4 is going to give us $24? 6. He had to buy 6 gallons of gas. Nicely done, everybody. Very good. All right, that was number 19. Let's take a look at number 20. Okay. All right. Getting into our proportions, right? Setting up equal fractions, right? Equal rates. Okay, so out of every $100 that Taylor earns at her part-time job, she saves $25 for college. Okay, the amount she saves is directly proportional to the amount she earns. All right, so again, we know our rates are going to be equal here. Every time she makes $100, she always puts 25 into her savings. Okay, if she earns $3,880 in 1 year, how much will she save for college? All right, so what's our first rate? What do we know Taylor does here? We're going to set it up as a proportion, so we're going to use 2 fractions that are equal to each other. We're going to compare 2 rates. So for every $100 that she earns, right, she is going to save 25. You can set it up like that, Maddie. It's just you would have to that would still work. It's just on the other side, you're gonna have it flip. I'll talk about that in a second. Hold on, I'll make a mention of it. Hold on, let's get the rest of this up here first. That'll make more sense. $25 saved. All right, so we're going to compare the amount that she earns to the amount that she saves. So we're going to set up another comparison right over here. Again, we know that these rates are going to be the same. So we're going to compare, again, how much she earns to how much she saved. All right, so in our comparison, do we know how much she earned? How much did she earn in the 1 year? Go back in the problem. How much did she earn? Yeah, 3,880. Do we know how much of that she saved, or is that what we're looking to find? Yeah, that's what we're looking to find. So what am I going to put down here for amount saved? You got it, Laura. We're going to put X. Very good. That's our unknown. That's what we're looking for. So, Maddie, to respond to your chat before, okay, you can totally set it up as saved versus earned. You can totally set up your proportion like that. That is not wrong. Okay, you just have to make sure that your other side matches. Okay, you still want to make sure that if you're comparing the amount of money that she saved to the amount of money that she earned, that you do it in the same manner on the other side of your proportion. That is fine too. Okay, you can solve it and you'll still get the same answer. All right, so strategies to solve this. How do we need to, what process are we going to need to do in order to find the value for X? How do we solve a proportion? Not divide, but multiply. Who remembers cross multiply? Well, coming back to you. All right, we're going to cross multiply. So we're going to multiply in one direction. 100 times X is 100X. Go ahead, Anna. Then we're going to multiply in the other direction, right? 25 times 3,800. That's going to give us 97,000. All right, how do we solve for X? I don't want to know what 100 times X is. I want to know just X. So how do I figure that out? You got it, Laura. Divide both sides by 100. So how much money did Taylor save? If she earned $3,880, how much money did she save of that? Yeah, $970. Very good. Very good. All right. Nice job. Did anybody think of a different way to solve this? Anybody try a different strategy? Anybody try percents? What percentage of her money? She saved $25 for every 100 she earned. What percentage of her money did she save? She saved $25 out of every 100. What percentage does that work out to? 1/4, which is 25%. You got it. So we could have taken 25% of her amount that she made. We could have taken 1/4 of that. Okay, and lots of different strategies. It did tell us to use a proportion. So that's the way that I wanted to put that up on the board, but it's definitely more than one strategy for this one. Okay, let's tackle next, number 23. Ooh, when you look at this graph, what kind of proportion are you seeing? It's definitely not a direct proportion. Inverse proportion, you got it. Our graph is sloping downwards. Inverse proportions have not a straight line, it's a curved line, okay? We can still use our shortcut here for part A. Again, they do tell us it's an inverse proportion. It's like we're talking about delivering of flyers, right? So they're comparing how many students there are to deliver the flyers to how many hours it will take them to accomplish that task. All right, so I'm going to pick out some points on the graph here. There's already another one listed on here. Okay, remember inverse proportion. Our x times y has to equal our k. You can still use this shortcut, that same shortcut to find the constant that worked for our direct proportion will work on our inverse proportion as well. All right, who's got the constant for me? Addie sent it over in chat already. She's on it today. Laura knows. Elizabeth, Bryn, Maddie, Yangi, Carmen, what are you guys thinking? You got it, Autumn. Nice job. Remember, Tony, you want to multiply, not divide. X times y for our inverse proportion. All right, you can use this coordinate point right here. 6 times 2, x times y, going to give us our constant in this case, which is 12. Again, you can use that secret spot, right? When x is 1, you can follow that up to the line and shoot right over. That will also give you your constant, okay? That works on inverse and direct proportions. All right, let's write our equation. Again, you can use this, just substitute in your K value, that's all you need. That would be for a direct proportion, Elizabeth. Use this setup. X times Y equals K, just sub in the K. All right, here's our equation. X times Y equals 12. Okay, again, if you want to put a little multiply sign in there, you can. Usually it's left off though, because we assume that when the numbers are right next to each other, it's multiply. All right, let's describe the relationship between the number of students and the time needed to deliver the flyers. All right, so basically, what does this constant of proportionality mean? What does 12 mean in the context of this problem? Mm, 12 hours. Keep going. Takes 12 hours for what to happen? You got it, Maddie. It takes 12 hours for one student to deliver the flyers. Nicely done. All right. So now that we know what the constant means, what does the 0.62 represent in this situation? We go further down the graph. We land on 6.2. What does that mean? You got it, Anna. 6 students. Take 2 hours to deliver. Fires. You got it. Nice job, right? So pay attention to those labels on the X and Y axis, right? Pay attention to that, right? Because that's going to help you determine what does the constant mean, right? And also what the points represent, right? 6 means is on the X axis, it's the X value, so that's the number of students. 2 is the Y value. The units on the Y value are the hours it takes. Okay, all right, we've got time for one more. Let's do a percent problem. Number 25 is a percent problem. Let's finish strong with this one on page 366. A company begins a new product line and needs to increase the number of employees by 16%. The current number of employees is 650. How many employees does the company need? Again, with these percentage problems, there's a handful of ways that you could tackle them. That's part of the answer, Tony. How many total employees are they going to need all together? There you go. All right, who can share how they set up this problem? What was your first step? What were you thinking? What was your strategy? Tony, you want to tell us what you did? You sent me the right answer in chat. How did you set this up? What was the first thing that you thought of? Finding 1%. All right, excellent. 1% of 650. All right, what did you find was 1% of 650? Nicely done. Okay, then what it is, you got it, 6.5. What'd you do with that information then? Once you knew 1%, what could you do with that? Yeah, multiply it by 16, right? If we're looking for 16%, right? If 1% is 6.5, we can multiply it by 16 and get 16%. Very good. All right, that gave us 104 more employees. All right. Okay. If they need 104 more employees, how many employees does the company need to have altogether? We would have to take our additional employees and add them to the original bunch. You got it. 100 or 754 employees in all are needed. All right, that gets you there. Did anybody do something different and still got 754? Like I said, there's lots of different ways. Did anybody start off by taking 16%? Addie, what did you do? Sorry, I missed your hand. My bad.
That's okay. I just times 650 by 1.16, which got me 1.4. So just using mental math, I know that 1.104 plus 650 is automatically 754.
Nice job. All right. So yeah, if you took 16% of 650, very good. Right, you would have gotten your 104 extra employees, and then you added that to the original and still landed on 754. Did anybody remember the way to do it all in one step? Again, it doesn't matter to me what strategy you do, but I'm curious, who knows how to do it all in one step? Who can get 754 in just one move? Challenge. Ah, you got it, Laura. Nice job. Laura said, ooh, I can do it in one step. I know that if they want 16% extra, I'm going to have to include the original 100% of the people. So if I multiply I multiply 116 over 100, right, times my 650, I would get to my total number all in one step. Nice job. All right, again, any of these strategies work, whatever one you did works for me. All righty, guys. Woo. We are already at 9:52. So we've got time for a quick exit ticket question here today. How do we write a direct proportion equation? What is the magic outline that we're looking for? You got it, Yangi. Nice job. Very good, Elizabeth. Addie knows. Laura knows. Nicely done, guys. You got it, Anna. There you go, Bryn. Ooh, I think you meant an equal sign there, but yeah, that's correct, Maddie. Very good. Y equals, you got it, Tony, K times X. Very good. All you need to know is the K. If you know the constant, you can make a direct proportion equation and you can make an inverse proportion equation. Nice job, Autumn. You got it too. Very good, guys. All right, finish up that review for today and tackle that test. Again, it's got to be submitted to me by tomorrow, which is January 16th at 4 p.m. Okay, you're going to see new course Bs populate today. So that will be for next week. Again, they do have new Zoom sessions, so keep that in mind. They'll all be linked right in the new course. All right, I will see you guys for skills today. Thanks very much. Bye, everybody.